Hello dear students, welcome back to NEET World. So this is our IPE session for class 12th chemistry students. So whether you may be BPSC student or MPC students, definitely you need to study this chemistry right now. So now this is our session 2 for chemistry 60 by 60 for upcoming IPE exam. Okay, so now in the last session I have given you the important questions related to IPE chemistry part. Right now, class 12 IPE chemistry part that will be very useful for both AP and Telangana state students right now. So now again along with that I have shared blueprint as well as I have also explained the question, that is LAQ question related to electrochemistry, that is Kohlrausch law. We have discussed very clearly each point to point, and I told you how to access the notes. See, this is our C60 by C60 by C60 book, and this booklet is for your IPA preparation. So what I am going to do is, so from this book I have made this book for your IPA exam only. Okay, so now from this book I will be reading one line by line, and you can note that line by line each sentence, everything, and you can make your own notes, and also each point here whatever I have written I will be explaining to you, so that everything that present in this book will be clear to you, so that you can make your preparation more effective right now. So now here just look at this. So these many chapters are there. So first of all we are discussing electrochemistry and chemical kinetics, which has a 8 marks LAQ question right now. So once after finishing that we can again focus on to the 8 marks question, that is from organic chemistry as well as P block. Like that we will be finishing first LAQs, then next SAQs, and at the last we will be discussing 2 marks, that is very short answer type questions. Okay, so if you follow our sessions on this IP 2026 and the upcoming exams, so definitely you are going to get 60 out of 60 if you follow effectively, and you can make your own notes, because we know IPE questions will be repetitive. If you look at the past papers, most of the questions are repetitive multiple times right now. So those questions you should not skip first. So those questions, all those questions I have brought here, I will be explaining each and every question from those past papers. Okay, so just follow our sessions, whether you might be preparing both, I mean MPC BPSC students, like all subjects are discussed here. We are not only covering chemistry, we are covering physics as well as biology and mathematics also. Okay, right. So without wasting our time on any other further discussion, let's start discussing the question. See, I have in the last class I have explained you about Kohlrausch law. So if you have watched my last session on this Kohlrausch law, you might be clear with this Kohlrausch law now. Okay, so if you haven't watched this, so you just go to the previous, I mean last session on this class 12 IPE Kohlrausch law we have discussed. After this session you can watch it and make your preparation effective. Okay, right. So look at this. The next question here is, see, we have a question from chemical kinetics, like what do we mean by molecularity, order of reaction. This should be covered, and before going to this I just want to finish the important questions related to electrochemistry first, and after that we will come back to the chemical kinetics and we will clear all those questions. Okay, right. First of all, look at this question here. See, this is second important question from electrochemistry. First one is Kohlrausch law and second one is galvanic cell. Okay, so electrochemical cell or galvanic cell, they will consider it. Okay, now tell me, what are galvanic cells? So this is also most repeated question. So what are galvanic cells? Explain the working of a galvanic cell with a neat sketch taking Daniell cell as an example. And this is part A question, and part B question will be what are fuel cells? Give the construction of H2O2 fuel cell. Okay, hydrogen fuel cell they are asking. So these are the two questions. They are making it as part A, part B, like A, B, and they are asking it as a 8 marks question, like 4 marks each. Or you can also expect one more question, that is this one, electrolysis. What are the different types of batteries we can expect? Electrolysis question also you can see. See here we have what is electrolysis? Give first law of electrolysis or second law of Faraday's electrolysis, they will ask. So these are the questions to be focused from electrochemistry. So let me finish these questions whatever I have highlighted till now. So first one here, just see here, what is electrolysis? Give first law of electrolysis. See, what do we mean by electrolysis? First of all, tell me. So electrolysis is nothing but we are passing electricity through the through some solution, and with the help of that electricity, whatever electricity we are passing externally, with the help of that electricity we are making a chemical change, we are making a non-spontaneous chemical reaction. See, generally if there is a chemical reaction, see what you know guys, see before explaining this question directly into the question, I just want to give you some basic idea. First of all, you know chemical reactions are two types. It can be a spontaneous one, and other one is non-spontaneous. Okay, so now a non-spontaneous chemical reaction means it won't happen on its own, it requires someone's help from outside. Okay, a spontaneous reaction can take place on its own and produces the products during the chemical reaction, but a non-spontaneous reaction cannot take place on its own. Okay, so it means it requires some help from some other things. For example, by increasing the temperature or by making it, by passing some electricity, that non-spontaneous chemical reaction can take place. For example, conversion of, like we have NaCl now, so now you need to convert this NaCl to chlorine gas. So for this production, what we can do, it cannot happen on its own, like naturally it won't happen, so that we can say a non-spontaneous process. So for this, so these chloride ions are there now, so now what I am doing is I am passing some electric current. So electric current, when we pass this electric current through that, so this chloride ions will convert into chlorine gas. Okay, so what is this process? This process is called electrolysis. What I am saying, electrolysis. So just look at here what they are saying. Let me check whether everything is clear. Is it visible? It is clearly visible now. Yes, it is clearly visible, right. So just look at here, the process of chemical deposition of an electrolyte by passing an electric current through the electrolytic solution. For example, here in this beaker we have NaCl solution. What I am saying, NaCl solution is there. So from this NaCl solution I want to produce a chlorine gas. What I want to produce? Chlorine gas I want to produce from this chloride ions. Okay, so now I will take two rods. What I am taking? Two rods I am taking. Okay, these rods will be like simple, like inert electrodes we can say, like platinum rod, graphite rod, so you can take. Okay, now this will be connected to a external battery, like battery or something like that you can take. So here a battery we are connecting. Now what happens, this battery produces electric current into this electrolytic solution. Okay, so since this battery have positive terminal, negative terminal, so here we have electrodes like anode, and cathode. What I am saying, electrodes like anode and cathode. So these are the two electrodes we have. First of all, anode contains positive charge. What I am saying, anode is positive terminal and cathode is a negative terminal. So now whatever the ions we have in this solution, NaCl means what are the ions we have? Sodium ion and chloride ion right now. So whatever the negative charged ions are there, those goes towards this anode side. Okay, because anode is positive terminal now, so opposite charges attracts right now. So whatever the negative charge is there, that goes to the anode side. So at anode what happens? At anode, chloride ion will be goes to anode. So now chloride ion will be there at anode. So now this anode, at anode oxidation takes place. What happens? Oxidation takes place. So what do we mean by oxidation? See, removal of electrons. How much charge you are seeing here? -1 now. So if I take one chlorine, that will be -1. So here I am taking two chloride ions. So now what happens is I am just removing this electron, so that it will gives two electrons plus a Cl2 gas. So it will become Cl2 plus 2 electrons will be released. How many electrons are releasing? 2 electrons are releasing. So removal of electrons means what is that process called? Oxidation. Now, so oxidation takes place at anode. Just remember this. See, I am not dictating what is there in the book. I just want to give you the concept. First of all, learn this concept, then read this point by point, then everything will be in your mind. So you no need of by hearting the things. Just learn it in a conceptual manner. Okay, so that you got here chloride ion is converting into chlorine gas. So where this chlorine gas is released? At anode. What is the process called? Oxidation. Okay, now at cathode what charge? Negative. It attracts cations. Cathode is an electrode which attract cations. Okay, the cations here we have Na plus. Okay, so Na plus ion we have. Along with this Na plus, see I am saying electrolytic solution. What I am saying? Electrolytic solution. Okay, so if you take electrolytic solution of NaCl, you have Na plus ions and H plus ions from water. Otherwise, if you take only molten NaCl chloride, like molten NaCl, sodium chloride, molten state means only in that Na plus ions are there, chloride ions are there. For example, I am saying this is a molten NaCl. So now we have anions went to anode, cations goes to cathode. Okay, cations attracted by cathode. So now this Na plus ion will be now converted into Na. So now what is the process here? It is taking sodium ion, sodium cation converting into sodium atom. So there is zero charge. Plus 1 converting into 0 means what should be the decrement in the charge? Plus 1 should become 0. It means you just add 1 electron. Electron means minus 1 charge now. So plus 1 minus 1. So it will be 0. So it means at cathode what is happening? Gaining of electron by this species. So gain of electrons is called reduction. So where the reduction is taking place? Reduction is taking place at cathode. Always remember, oxidation happens at anode, reduction takes place at cathode. Remember these two terms. Okay, sodium ion converting into sodium atom. So deposition of sodium takes place at cathode. Okay, and liberation of chlorine gas takes place at anode by oxidation. So I hope this example is clear. Just read the statements now. It is a process of chemical deposition. Yes, chemical deposition is taking place or not? Yes, taking place. Of an electrolyte, of this electrolyte. By passing electricity, by passing electric current through using this battery external current, we are doing this process. So by passing electric current through this electrolytic solution. Okay, so this process is called electrolysis. Okay, up to here it is clear. Now look at this. During electrolysis, what are the things we have seen? Oxidation is taking place at anode. Yes, oxidation, where it is happening? Oxidation is taking place at anode. Right now? Right. Next, reduction is taking place at cathode. Yes, reduction is taking place at cathode. Right now. So these 2 points are perfectly correct. Right. Next one, we have Faraday's law of electrolysis. What do we mean by Faraday's law of electrolysis? See, just now till up to here what you have studied that. So anions will deposit at anode, cations will deposit at cathode into respect to elemental forms or their molecular forms. This is what we have learned. Now, how much quantity of this chlorine gas is released at anode, or how much quantity of sodium ion is deposited as sodium atom at this cathode? So how much quantity we need to measure, like whether it is 20 grams, 30 grams, 40 grams of sodium, how many grams of sodium is deposited at this cathode, we need to calculate now. So that comes from this Faraday's laws. What I am saying, that comes from this Faraday's laws. So what Faraday says that in first law, Faraday's first law of electrolysis, what he says is the amount of substance like of sodium deposited at an electrode at this cathode will be directly proportional to quantity of electricity we are passing into this electrolytic solution. It means manam, I just want to repeat the same thing in Telugu, so because most of the students are from Telugu states. Okay, so no worries, I will be covering both in English and Telugu. So if you have any confusions, you just mention in the chat box. So I just want to check whether audio, video, everything is clear. Right. So just look at here what I am saying. See here, this is our beaker. Na? In this beaker we have electrolytic solution. So to this we are passing electricity. Now how much amount of sodium is deposited or how much amount of chlorine is deposited at their electrodes will depends on quantity of charge, quantity of this charge we are passing through this electrolytic solution. That's it. It means weight of substance deposited directly proportional to quantity of electricity passed through the electrolytic solution. It means ఈ beaker లో మనం molten NaCl తీసుకుంటున్నాం కదా. సో ఇప్పుడు ఇందులో నుండి ఎంత సోడియం ఆటమ్ డిపాజిట్ అయింది క్యాథోడ్ దగ్గర, లేకపోతే ఎంత క్లోరిన్ గ్యాస్ రిలీజ్ అయింది యానోడ్ దగ్గర అనేది మనం ఎంత కరెంట్ పాస్ చేస్తున్నాం ఈ బ్యాటరీ యూజ్ చేసి, ఎంత కరెంట్ ఈ ఎలక్ట్రోలైటిక్ సొల్యూషన్లోకి పాస్ చేస్తున్నాం అనే దానిపైన డిపెండ్ అవుతుంది. సో మోర్ ద చార్జ్ యు ఆర్ పాసింగ్, మోర్ ఇస్ ద క్వాంటిటీ ఆఫ్ substance deposited at that particular electrode. So that's how you need to understand. So this is what first law of Faraday says. So weight of a substance directly proportional to quantity of charge we are passing through that electrolytic solution. Okay. So from this I am writing weight is equals to here weight is equals to Z Q I am writing. So what do we mean by Q here? Just so weight is equal, I am just removing this proportionality, I am writing it as ZQ. So this is first equation, from that we got this. So Z is called electrochemical equivalent. Okay. Now weight is equals to Z into, this is charge now, charge means coulomb, units are coulomb. So charge can also be written as I, current into time. Okay, that should be second. So amperes into time in seconds, that is nothing but time, seconds into ampere gives this coulomb. So weight is equals to Z IT will be a formula to calculate quantity of a particular electrolyte, I mean particular substance deposited at particular electrode. This is what the first law of Faraday, that's it. If you write up to here by representing this diagram and all, you will definitely get your full marks, whatever the marks they are mentioning for that particular question. Okay. Hope the discussion is clear up to here. Yes guys, those who are clear with the session, I mean whatever we discussed, just click on the like button, and if you haven't subscribed to the channel, just click on the subscribe button also. Okay. Yes. And if you want, just mention any doubts or any confusions are there, mention in the chat box. I will repeat the thing. Okay. Do not worry. Okay. Do not think anything more than that. Just mention in the chat box. I will explain. Now one more thing, just see here, this is about first law of Faraday's. In case by chance they are asking about second law of Faraday, that is also very easy. Just look at here, see what I have taken, this is a beaker connecting to a battery, like that I told you now. So second law of second law of Faraday's, second law of electrolysis, Faraday's second law also almost the same. I mean you will get almost easy, you feel almost it as a very easy and similar to this. See, this is one electrolytic solution, this is one more electrolytic solution. Okay. Now both of the solutions, both of these beakers are connected to one point, that means one battery only. So here this is a battery I am writing, okay, like this, and here it is connected like this. So now what you are getting from here, see here positive terminal, negative terminal, everything is there. So now these two electrolytic solution, for example this is containing copper sulfate solution and this containing silver nitrate solution, AgNO3 solution, let us say. Okay. So now what is the quantity of copper deposited or what is the quantity of silver deposited, depends upon quantity of current passing through the electrolytic solution, that we know from first law of thermodynamics right now. So now how do they relate? What is the ratio of copper deposited, what is the quantity of Ag deposited, how do you get? See, whenever we are connecting the electrolytic solutions which are connected by series, which are connected in a series, the quantity of that particular electrolyte deposited, particular substance deposited from its electrode depends on its equivalent weight. So what do we mean by equivalent weight? See, copper sulfate means what you are writing, Cu plus 2 charge now. So plus 2 charge is there, means see generally copper means like this. What is the charge you are seeing? Copper plus 2. So equivalent weight is nothing but just divide its molecular weight by its n factor. What is the charge present on it? Plus 2 now. So plus 2, copper plus 2 converts into copper at this cathode. So molecular weight divided by its n factor. What is the n factor? It is 2. So simply you can write weight of copper deposited will be weight of copper deposited by weight of Ag deposited will be equals to equivalent weight of copper by equivalent weight of Ag. like this we need to take. Okay, so what is the equivalent weight of copper means molecular weight of copper by its N factor. N factor is how much for copper? It is 2, and for silver here it is plus 1 now. So molecular weight of atomic weight, this is not molecular weight, this is atomic weight of copper by here also atomic weight of silver by its N factor. What is the N factor? Plus 1 is converting into Ag, 0. It means plus 1 to 0, number of electrons gained are 1. So it is 1, this 1 by 1. So that's it. So this ratio gives quantity of copper to the quantity of Ag deposited this electrode. This is what second law of electrolysis, that is Faraday's second law. That's it. So these are the two things you need to remember. Mostly they will ask only first law of Faraday, Faraday's first law only. So this is what you need to indicate and you need to explain. The next question here we have is galvanic cell. So what they are asking, next one is galvanic cell. This is more important than the previous discussion because here it is more important. Mostly it is more repeated than the previous discussion. Now see what they are saying. What are galvanic cell? Explain the working of galvanic cell with a neat sketch taking Daniell cell as an example. Very easy. So galvanic cell means what exactly? See, in the previous case I told you about electrolysis, no? So while explaining electrolysis I told you there are two types of chemical reactions. One is spontaneous, another one is non-spontaneous. In electrolysis process, a non-spontaneous chemical reaction, it means by passing electricity a chemical reaction is achieved, like chemical process will be changed, chemical change is taking place. But here in galvanic cell a chemical reaction takes place spontaneously that produces electricity. What I am saying? A spontaneous chemical reaction takes place that produces electricity. Okay, so this is what happens normally. So what I am saying, a chemical reaction takes place that produces electricity. So look at here, a galvanic cell is an example of electrochemical cell. So a galvanic cell is an electrochemical cell that converts chemical energy into electrical energy through a spontaneous chemical reaction, chemical redox reaction. Okay, simple, you should not get confused between electrochemical cells and electrolytic cells. Okay, so these are what electrochemical cells produces electricity from a chemical reaction. Okay, a galvanic cell or a voltaic cell is an electrochemical cell. What I am saying, these cells are an example of electrochemical cells that produces or that converts a chemical energy into electrical energy. So how this chemical energy is producing? Through a spontaneous redox reaction. Okay, so I hope you know what do we mean by redox reaction. For example, here I am writing a simple example. I have zinc. So whenever you treat this with zinc with copper plus 2 ions, like copper sulfate solution, like that if you take, now what happens is, so this spontaneously react. Whenever you have zinc rod, okay, if you dip that in the copper sulfate solution, so you will be seeing some chemical reaction happening there. So what is that chemical reaction is happening here? So here zinc 0 oxidation state converts into plus 2 and copper plus 2 will be converts into 0, like this. So they are exchanging their charges. How do they that exchange is taking place? Now zinc is losing 2 electrons, that lost electrons are taken by copper plus 2 ion and converting into copper atom. Okay, so this is what happening in the electrochemical cell. So these things you are seeing in your daily life also. For example, if you see storage of some compounds, see if you take one storage box like metal things you can take like iron box or something like that. So if you keep some chemicals in that or pickles, if you keep in that, what happens? By after few days, that whatever the metal vessel you are taking, that will be getting rusted or some chemical disturbance, some damage happens sometimes, right now. So why it is so? It is simple because of these redox reactions only that are taking place spontaneously. Someone in the comment box. Right, what I am saying here, a spontaneous chemical reaction is responsible for generation of electric current, generation of electricity. Okay. So now how it happens, let us see. Let us construct a cell, let us make one cell by using this spontaneous chemical reaction. See, now what we are taking is construction of galvanic cell. So galvanic cell means it's an electrochemical cell, generates electricity from a spontaneous chemical reaction. So how this setup will be seen, will be discussing here. See, there are two half cells. One is oxidation half cell, another one is reduction half cell. So here we will be taking zinc sulfate solution. We are taking zinc sulfate solution. What are the things required? I am saying first. Zinc sulfate, we require copper sulfate. These are the two electrolytic solutions we require, because I am using two electrodes. What are those electrodes? Zinc electrode, that is zinc rod, and copper rod. What are the things I am using? Zinc rod, copper rod. Okay. So just take two beakers. What I am taking? Just take two beakers like this. Okay. So in one beaker I am taking zinc sulfate solution. What I am taking? Zinc sulfate solution. In another beaker I am taking copper sulfate solution. Okay. So now what I am doing is, this is zinc sulfide now. So in that I am dipping zinc rod. What I am dipping? Zinc rod. See, here it is already given, but you should feel that we are doing this experiment. Okay. So zinc rod is dipped in zinc sulfate solution, and similarly copper rod is dipped in copper sulfate solution. This is what? Copper rod. Okay. Now connect them like this. Now just connect them like this. So you are connecting them, and since what I told you, during a chemical reaction in this setup, electrical energy is generated. Now how much quantity of electrical energy is generated, that we need to check now. So for that I am connecting here some ammeter just to check the deflection here. Okay, right. So up to here it is clear now. So now if you see, this connection is only not completely filled, it is only half direction, one more half should be made here. So how can we make that? See, now what I am doing is, I am connecting, I am fulfilling this circuit by using something called salt bridge. What this salt bridge will do? So here a salt bridge, just look at here what I am doing. I am taking a salt bridge. This salt bridge is nothing but a U-shaped tube. This is called salt bridge. So in this salt bridge we will be taking KNO3 or NH4NO3 type of solutions mixed with agar-agar. Okay, this is a jelly substance that is filled in this salt bridge. What I am saying, it is called as salt bridge, because we are taking one salt, mixing with agar-agar, making that jelly like paste and filling in this. So what is the use of salt bridge? It will fulfill the electrical circuit, it completes the electrical circuit. So just read all these points. See, zinc half cell, in this zinc half cell what we have made here, zinc rod is dipped in zinc sulfate solution. Okay, and this zinc sulfate solution, this half cell is there now. So this is called anode half cell. Okay, what is that? Anode half cell. And other one is cathode half cell. Okay, now sir, how can we decide cathode and anode? So like the one which has more ability to undergo oxidation, now that should be taken in anode half cell, because in anode half cell oxidation takes place. What happens in anode half cell? Oxidation takes place on its own. So when it is undergoing oxidation, so what we are taking here, zinc rod now. So at anode, this zinc rod will undergo oxidation and gives 2 electrons out. Okay, so by losing 2 electrons, zinc is forming Zn plus 2 ion, which is called as oxidation. Okay, so now here we have cathode now. So at this cathode, what is the electrode we are taking? Copper electrode now. So in this we have copper sulfate solution. Copper sulfate solution means there will be copper plus 2 ions in the solution. Copper plus 2, because sulfate now, Cu plus 2, here Zn plus 2 in zinc sulfate solution, like that we have. So whatever the electrons released at anode, that electrons move from here to like this to like this. So electron is flowing from where to where? From anode half cell to cathode half cell, electrons flow is taking place. Okay, so at cathode what happens? Here we have copper plus 2 ions, that copper plus 2 ions take these 2 electrons and converts into copper metal, like this copper solid will be deposited. Okay, so this is what the transformation is taking place. So at anode oxidation is taking place, at anode oxidation is taking place, at cathode reduction is taking place. Reduction of copper plus 2 ion into copper metal is happening right now. That is at what? At this cathode it is taking place. You need to write these points, that's it. Whatever we have discussed with using this experimental setup, you just need to write them point by point. See, construction of galvanic cell, it consists of two half cell, one is anode half cell, other one is cathode half cell. So you need to take anode half cell, that metal which is more reactive, means which has more tendency to undergo oxidation. So zinc has more tendency to undergo oxidation when we compare with copper. Therefore, since zinc oxidation potential is more, that's why I am taking it at anode. So now zinc loses 2 electrons undergoing oxidation, and that 2 electrons transfer from this anode to cathode. So now that cathode here will give the 2 electrons to the copper plus 2 ions, and copper plus 2 ions will undergo reduction to copper metal. So here you can say deposition of copper is taking place. Okay, here the copper zinc rod here converting into Zn plus 2 ions at the anode. You can remember these 2 points. See, a copper half cell, a copper rod is dipped in copper sulfate solution which is act as an cathode. Okay, then next, the 2 metal electrodes are connected externally by a metal wire through a voltmeter. Yes, here we have a voltmeter. Through this external circuit is fully filled. Now the 2 solutions are connected internally by a salt bridge containing inert electrode like KCl or ammonium nitrate NH4NO3 to maintain electrical neutrality. So because from here to here electrons are moving now, here all what we will be having now, all zinc plus 2 ions are formed here because electrons are moving from here to here. So whatever the plus 2 charges generated here by zinc, that will be more here. So now we need to neutralize them, otherwise completely this solution becomes positive now. If that solution becoming positive, electron flow will not take place further, therefore cell will not work. So now what we will be doing is, in this salt bridge we are taking KCl or KCl or what I told you, KCl or KNO3 or AG NH4NO3 we are taking now. So that will, here if it is forming Zn plus 2 ions, now what are the anions present here in this KCl? If I take, chloride ions will be there now. So that chloride ions from these salt bridge comes and neutralizes this Zn plus 2 as ZnCl2 or some whatever the anions we have, that will come and neutralizes this plus 2 charges. That is what they maintain electrical neutrality. Okay, now if I move this side, so if what happening here, so the electrons are coming from here to here, all copper plus 2 ions are converting into copper metal. Now what are the other part we have? So out of this CuSO4, Cu plus 2 ions are converting into copper metal. Now sulfate ions are remaining as it is now. So these sulfate ions means nothing but negative charges. That negative charges also should be balanced, like neutralized. Otherwise here it becomes more negative, that won't allow this negatively charged electrons into it right now. Therefore sulfate ions should get neutralized. For that purpose, what is the cation mentioned in the salt bridge, like K plus ammonium plus ion, like that we are taking now. So that potassium ion or ammonium ion, whatever we are using in the salt bridge, come into this solution and that will neutralizes the sulfate ions whatever we are taking. Therefore complete electrical neutrality is maintained. Okay, so from this external circuit, electrons will flow. Okay, what they will flow? Electrons will flow, and here this ions maintains an electrical neutrality from this salt bridge. Okay, okay, this is what the points here I have mentioned that you need to show during the exam. Okay, right. Right, and the next after this what to know more about this. So here what happens at anode? At anode all the time oxidation takes place. At anode what happens? Oxidation takes place. What do we mean by oxidation? Oxidation means a loss of electrons. See, that zinc rod whatever we have taken, what it is converting, zinc is converting into Zn plus 2 now by releasing 2 electrons. So that reaction you need to mention that working. At anode oxidation is taking place. This is what the reaction you should maintain. Okay, so here zinc rod na, that is in solidity form, you need to mention its physical states also. Now it is converting in Zn plus 2. Now this is aqueous state. Okay, this is what aqueous state in its ionic form. Now at cathode what is happening? Copper ions from the solution, copper sulfate solution, gains the 2 electrons that are coming from anode and deposit as a copper metal. So aqueous Cu+2 ions now convert into solid copper metal. Okay, so the weight of copper rod here increases because copper is deposited here now, so weight of copper rod will be increases. Here weight of zinc rod will be decreases. So this is how you need to understand each and every point. So this will be utilized, useful for your IPE exam. Along with this, same content will be very useful for your upcoming JEE, NEET or EAP set exams also. Okay, so if you haven't preparing for your EAP set also, yes, this whatever we are discussing, this discussion is helpful. Whatever we have made till now discussion, whatever the discussion, all these points are very useful for your other exams also, like EAP set, NEET, JEE also. Okay, right. So up to here it is clear now. So what are the ways to write this exam? How do you present this in your exam? So first of all, write the definition. Okay, so what is the definition? What do we mean by electrochemical cell? Electrochemical cell ante enti? Ante em rastaru? So just need to mention an electrochemical cell is a cell which converts a chemical energy into electrical energy by a spontaneous chemical reaction. Ante enti? Electrochemical cell anedi ఒక కెమికల్ ఎనర్జీని ఎలక్ట్రికల్ ఎనర్జీ లాగా మార్చుతుంది. ఓకే, బై ఏ స్పాంటానియస్ రియాక్షన్, అంటే ఇందులో ఒక స్పాంటానియస్ కెమికల్ రియాక్షన్ ద్వారా కెమికల్ ఎనర్జీ అనేది ప్రొడ్యూస్ అవుతుంది, అది కాస్త ఎలక్ట్రికల్ ఎనర్జీగా మారుతుంది అనేది మీరు రాయాలి ఎగ్జామ్లో, అంతే. సో దట్ ఈస్ వాట్ గాల్వానిక్ సెల్ ఆర్ ఎలక్ట్రోకెమికల్ సెల్ సేస్. ఓకే, దెన్ నెక్స్ట్ హౌ టు కన్స్ట్రక్ట్ వన్ ఎలక్ట్రోకెమికల్ సెల్ అనే దాన్ని మనం ఎగ్జాంపుల్ లాగా ఇలా చూపించాలి. ఓకే, సో యూ నీడ్ టు టేక్ 2 beakers and one beaker contains zinc sulfate solution, other beaker contains copper sulfate solution. Dip 2 rods in zinc sulfate zinc rod, copper sulfate copper rod, connect them through a external wire and just adjust one voltmeter just to check whether it is really generating current or not, really electricity is generated or not, we need to check now. So that's why we need to connect one voltmeter here. Okay, and the next what here we have, and see only half circuit is full, so in order to fulfill I am using a salt bridge. Salt bridge is nothing but a U-shaped tube we are taking, in that we are filling with agar agar gel that is mixed with inert electrolyte like KCl or ammonium nitrate. Okay, we should not take everything, like NaCl is not preferred here, only KCl or ammonium nitrate kind of electrolytes only used here. Okay, because that cation anion should have a equal transport numbers, that is not required, just whatever the example mentioned here, just write it those in the exam, that IPE exam, that's enough. Okay, and the next here what is the working place? At anode what happening, at cathode what happening, write that, that's it. Okay, so now overall reaction, what is the overall reaction you are seeing? What is the overall reaction you are seeing? Just tell me what is happening for the overall reaction. So at anode zinc is there, at cathode copper +2 ion is there. So now zinc is converted into zinc Zn+2 ion, copper +2 converted into copper 0 oxidation state, that's it. So this is the chemical reaction, net chemical reaction is taking place in this galvanic cell, like whatever the cell we have discussed. So this is what happening, so you need to represent that. Okay, now they will also ask us to represent cell representation. What do we mean cell representation? During the reaction you have seen the diagram, so you have first anode we have written, and the next cathode we have written. For connecting them we are using a salt bridge. Now salt bridge you should indicate with a double slash. Okay, this double slash indicates between anode and cathode, double slash indicates salt bridge. So at anode what is happening, zinc elemental form is converting into Zn+2 ion, so Zn 0 converting into Zn+2. So why I am using a single slash here? See, zinc here it is in solid state right now, and here Zn+2 in aqueous state. Okay, whenever you have different phases, that should be indicated with a slash. Okay, that should be separated with a slash, like this. Okay, after this represent the salt bridge, and what is happening at the cathode reduction now, it means copper +2 is converted into copper metal, again here +2 aqueous ionic form, this is elemental form solid. So this is what happening. So at anode oxidation, at cathode reduction taking place. So this is how you need to represent your cell. Okay, galvanic cell or electrochemical cell you can indicate like this. Okay, so right. So everything is discussed up to here. So see here, during the reaction, electron flow from zinc to copper through the external circuit, and electrical energy is produced due to this electron flow. What happens? Electrical energy will be produced during this electron flow. Okay, right. Next thing here is cell potential. It means during this complete chemical reaction, during this spontaneous reaction, how much energy is produced. Like we are saying now, how much cell potential is developed. What we know? So during this chemical reaction, definitely there will be some energy produced. During this chemical reaction, electrical energy is produced. So how much it is produced, that we want to know now. So now what is happening at this anode? Oxidation. Now you can write it as E, oxidation is taking place now. So you can write E naught of this Zn converting into Zn plus 2. Okay, place E naught of copper plus 2 is converting into copper. Like this we can indicate for calculating. Sir, how do we get these values? Yes, there will be some fixed values for this oxidation and for this reduction. That values, if you substitute over here, you are going to get your E cell value. Okay. So now most of the cases that values will be provided for reduction halves, not for oxidation. See, this is a reduction or oxidation. See, 0 is converting into plus 2 now. This is oxidation. This is not a reduction. But what I told you in books also, if you observe, they will be giving it as a reduction half values. Okay. How do they relate? So for a reduction half, if it is negative, oxidation half will be positive. That's it. So here it is oxidation half now. If I want to write in reduction half, so just I need to insert a negative sign here. So minus E naught of Zn plus 2 is converting into Zn. Okay, plus E naught of Cu plus 2 is converting into Cu. So simply you can generalize this formula as E naught cell is equals to where this process is taking place at anode now. So anode will be having negative reduction potential. Okay, so it means E naught of cathode, I can write E naught of cathode, which is positive, E naught of cathode minus this one, E naught of anode. Okay, these both values can be given in terms of reduction potentials only. So if you write up to here, that is also fine. You can extend this so that you will get a standard formula, like bookish formula like this. That's it. Okay. Now if you want how much energy is generated, how much voltage is created here, if you want to calculate EMF generated here, is simply, see, I know the values, that's why I am writing here. So for copper, reduction potential value is 0.34. What is that value? Plus 0.34. And for zinc, reduction potential value is minus 0.76 minus 0.76. Okay, by simply adding these two values, how much we will get? See, minus of minus, it will be plus now. So it means 0.34 plus 0.76. Okay, so 4 plus 6 is 10. So 10 means 0, 1. So 3 plus 7 is 10 and that 1. So it will be 11. Okay, so how many decimals? 2 decimals. 1, 2, 2 decimals are there. So it will be 1.1 volts is generated during this process. Okay, this is how you need to represent. Okay, so write in the same manner and give this type of example, then he will definitely impress and he will give full marks in the exam. So this is how you need to present in the exam with a clear cut understanding. Okay, so guys, do not sitting and listening won't give you full marks. Just what to do within this discussion. Now once after completing the discussion, just pause the video and try to make your own notes, own class note, on this class notes for your IPE final exam. Definitely you are going to get 60 out of 60 if you make proper notes. How can I present during my exam, final exam? Okay, you just make your final presentation now itself. Okay, take one paper, write complete answer. That seems to be like the same answer you are going to present in the final exam if this kind of question is present in the exam. Okay, so if you make in that format, definitely you will get full marks. Okay, because we know you don't need to have to take too much stress or burden, because every IPE exam there will be repetitive of questions. Okay, just make the answers for those those questions first, and if you have more time, you can prepare for other questions also. First of all, make such kind of important questions. See, for example, I am saying, in case if this question not coming in 8 marks question, same question may appears in 4 marks. Okay, so there is maximum chances to happen in that way, because see, if 8 marks question is from chemical kinetics, definitely the 4 marks question should come from electrochemistry. That may be again either Kohlrausch law or this galvanic cell or that electrolysis cell, or these multiple questions may also come in the exam. Okay, so this is what I am saying. In the last class we finished Kohlrausch law right now, so must be clear with that. And in this class we are discussing this galvanic cell, electrolysis, and next fuel cell. Okay, if you are clear with these 3 things, definitely there is one 8 marks question in your hand from your class 12th syllabus, or at least one 4 marks question in your hand for your class 12 IPE exam. This is for sure, definitely for sure. Okay, right. Then next, what up to here we discussed now. See, thus a galvanic cell is a primary example for a galvanic cell that generates electrical. Daniel cell is a perfect example. I mean, primary example for a galvanic cell that generates electrical current from a spontaneous chemical reaction. Through this spontaneous chemical reaction, electrical energy is generated with this much potential for this particular cell. Okay, this is what the final conclusion. Right now, next. So now, what are fuel cells? See, these fuel cells are having many applications also. Okay, so the best example for fuel cell is hydrogen oxygen fuel cell, H2, hydrogen fuel cell or hydrogen oxygen fuel cell we can consider. So what this fuel cell says here, see here, a fuel cell is an electrochemical cell. This is also an electrochemical cell. So I am erasing this, the previous discussion we did on galvanic cells. Okay. Okay, look at this. What they are saying? A fuel cell, electrochemical cell that converts chemical energy of fuel into electrical energy. That's it. So electrical energy is produced here. So what is the fuel here you are using? So we are saying now H2O2 fuel cell. So here hydrogen is our fuel. What is our fuel in this cell? Hydrogen is our fuel. So chemical energy of a fuel. What is our fuel here? Such as H2. So here you can use H2 or hydrocarbons like methanol also you can use, or other hydrocarbons which upon combustion produces energy, right? That energy will be converted into electrical energy. That chemical energy will be converted into electrical energy. The more efficient fuel cell here is hydrogen oxygen fuel cell. That's why we are discussing about that, and which is important in our exam point of view also. Okay, so here see how do we construct this. First of all, the fuel used here is H2 and an oxidant such as O2 is used. What is the oxidant here? O2. Okay, so now this O2 will oxidize our H2. Simple. If you take any combustion reactions which produces heat energy, like combustion of hydrocarbons like methane upon combustion, what we require? Oxygen is required, no? So there oxygen is our oxidant. Here also oxygen is our oxidant. Upon combustion, what is producing there? CO2 plus H2, because there is carbon, that's why it is giving CO2. Here we have no carbon, we have only hydrogen. No? Definitely it will give H2O only, not any other thing. H2O will be produced as a product. Okay, only H2O is produced as a product along with the energy. Okay, so now what we are doing here actually, construction of H2O2 fuel cell. So it consists of 2 inert electrodes. What I am saying, it consists of 2 inert electrodes. See, this is one electrode and this is one more electrode here. Okay, so now these are porous electrodes, like small holes will be there. Okay, so now this side small holes are there. I am saying now pores are there now. So that will be catalyzed also, like metal will be used, something like palladium, platinum to catalyze this process. Okay, it consists of 2 inert electrodes made up of either carbon, that is nothing but graphite, or platinum. Okay, graphite or platinum. Okay, used in a concentrated, placed in a concentrated NaOH or KOH solution. So these are 2 electrodes. So in between that we have aqueous electrolytic solution. I mean concentrated KOH or NaOH solution will be there. Okay, what we have? KOH or NaOH. Hydrogen gas supplied to the anode So anode here we have that will be supplied with hydrogen gas. What is it is? Hydrogen gas. Now see, again remember, in electrochemical cell our anode charge will be negative. What I am saying, in electrochemical cell anode charge is negative. In electrolytic cell, that electrolysis process we discussed now, their anode charge is positive. In electrochemical cells anode charge is negative. So do not always confuse with this negative positive charges. Do not think that anode means negative, cathode means positive, like that. Just think that at anode oxidation is taking place. What happening? At anode oxidation is taking place. Particularly if you want, in electrolysis process anode is positive. Anode means attracts anions. If it is attracting anions, that should be positively charged, because anions are negatively charged. That is the scenario in electrolysis. Now here we are discussing electrochemical cells. Now in these electrochemical cells anode is negative. What I am saying, anode is negative. Okay, so that negative is generated because of electrons. In electrochemical cells, why we are representing anode with negative charge? Because electrons are coming from that anode part only now. So since electrons are coming from there, that will be electrons are negatively charged. Due to that reason only, here we are writing negative charge on this anode. Okay, so now what happens at anode? So this hydrogen gas is continuously supplied to this porous anode. Okay, this inert carbon graphite will be taking now. So to that we are passing this hydrogen gas continuously, and see, hydrogen gas is continuously supplied to the anode side, and oxygen gas to the cathode side, and from this side you can see O2 gas is supplied. Okay, so now what happens taking place at anode and cathode? So at anode we know oxidation is taking place. Whatever might be the like cell, always remember at anode oxidation takes place. So now at anode what is the gas? We have hydrogen gas. So this hydrogen gas along with this KOH, concentrated KOH, and undergoes oxidation. When it is undergoing oxidation, what is happening? Just observe here. So 2H2 plus 4OH minus forming H2O plus 4 electrons are releasing. It is simple ma. At anode we have hydrogen gas na. So this hydrogen gas is converting into H plus ion. Whenever we are breaking this and converting into H plus ion, so if it is one molecule, it gives 2 electrons. It gives 2 electrons. If I take 2 molecules, it gives 4 H plus ions, because 4 hydrogen atoms now converts into 4 hydrogen cation and releases 4 electrons. Releases 4 electrons. Okay. Okay, that is what the reaction mentioned here. Okay, and the next along with this, see here at cathode, what is cathode? So at cathode, if you observe, reduction takes place. Whatever the cell may be, reduction always happens at cathode. Okay, so now what is coming towards the cathode? Oxygen now, so that will undergoes reduction. Okay, O2. Now how many electrons released here? 4 electrons now. That 4 electrons are taken by our cathode, and 4 electrons will be added to this oxygen. Okay, plus 2H2O gives 4 OH minus ions. Now just look at the net cell reaction here. So this 4 hydroxide ion, this 4 hydroxide ions are removed. Remember, in any chemical reaction, in any redox reaction, if you are writing any redox reaction, the total electrons that released in oxidation should consume in reduction process. How many electrons are released in oxidation? 4. That is completely consumed here in reduction. So you can cancel out them. So because here arrow mark is there now, so LHS, RHS you can cancel out. So what are the remaining things? So 2H2 plus 1O2 giving rise to, here 2H2O is there, 4H2O is there. So 4 minus 2 is, you can write 2H2O. That's it now. So that's why finally you are writing 2H2O. So what is the net reaction you are seeing? H2 plus O2, that is 2H2 plus O2 giving rise to 2H2O. That's it. This is a net chemical reaction taking place in this hydrogen oxygen fuel cell. That's it. So if you represent in this way with a rough diagram of this setup of this hydrogen fuel cell, definitely you are going to get a full marks for this particular question. Okay, so hope you are clear with our discussion till whatever we did. Okay, now if you have any confusions or any doubts, and if clear, just click on the like button, and if you click on the subscribe button, and you can share with your friends, those who are preparing for IPE. So I hope this is the best platform you can have for your IPE preparation effectively, because we are providing free study material here. Okay, so these are the final study material you can take. Okay, and we are explaining each and every line that you are going to study from this line, from this study material right now. Okay, so it means you can make your preparation more and more effective this way. Okay, right. Next, like this, you can also join in our Telegram that is will be provided in the description box. And if you want to get this access to your this materials, you can just go app, that is Med World app. What I mean, Med World app, download it from Play Store. It is our Med World app. Just search Med World app in the Play Store. You will definitely get this. Okay, so download this, and in this Med World app you are going to get this whatever the PDF we are discussing here for your IPE exams. Okay, right. You can download that and you can utilize it properly for your exam preparation only. Okay, right. Next thing here, what is finally what we have seen? Hydrogen gas is oxidized at anode and releasing electrons. Yes, 4 electrons are released. Oxygen gas is reduced at cathode, consuming those 4 electrons. Okay, the next, continuous supply of H2 and O2 keeps the cell working and produces a steady electric current, and there is no wastage also. During this process, what is produced? Only H2O is produced. Now water is produced. See, you know, these hydrogen fuel cells are used in rockets. Okay, so rockets launching and all, so there it will be acting as a fuel. See, whatever the byproduct formed here is water, so that will be utilized for their personal purpose also. I mean, during the process, during their journey, I mean that process. Okay, the rockets. So it means there is nothing wastage here. Everything is useful, because and this cell is also very efficient now. So that's why it is very good application. Okay, next, advantages H2O2 fuel cell, highly efficient. This is having high efficiency and eco-friendly, produces only water as a byproduct. That's why it is one of the very good advantage. Okay, next, continuous supply of reactant gases ensures the constant power output. So we need to supply continuously this hydrogen gas, oxygen gas, to ensure that output is perfect. The next, used in spacecrafts and submarines and electric vehicles. Okay, so this application also you can remember, used in spacecraft, submarines and electrical vehicle. Okay, these are the things. And the next question here we have is the different types of batteries, and explain the construction and working of this each type of battery. Okay, so this question we will be discussing in the upcoming session, that is tomorrow's session or day after tomorrow's session. That will be like our sessions, I mean our discussion IPE will goes on continuously without having any lagging or disturbances during this process. So what the only thing you need to do is you just click on the subscribe button and stay connected with our NEET World channel. Okay, right. So you can utilize physics, chemistry, mathematics, bio parts for your preparation, and you can have a very good score in your final exam. Thank you for watching. Stay connected with our NEET World YouTube channel. Thank you. Wow, 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 wow.